Chapter 11, Section 6, in the 8th grade note-taking guide, is entitled Systems of Equations. Now, we've actually already worked with systems of equations earlier this year, so this is, again, really a review, just like everything in this chapter is. We've done solving regular equations. We've solved inequalities, as we saw at the beginning of Chapter 11 here. Here we are doing systems of equations. When we did systems of equations earlier this year, we solved them with the substitution method, the elimination method, and Cramer's rule. Really, they're going to focus on substitution and elimination style methods here, not so much on the Cramer's rule, but you're welcome to use any of those methods if you can recall how to do them properly to solve the systems of equations. So let's review. What is a system of equations? A system of equations is a set of two or more equations that contain two or more variables. Really, that's exactly what they're going to focus on here in this section. Two equations with two variables, x and y. But truth be told, the system of equations can be any number of equations. We can have 3 equations and 3 variables, 4 equations and 4 variables, 5 equations and 5 variables, whatever we need. The solution of a system of equations is the set of values that make all the equations in a system true. If you recall from earlier this year, what that is the values that when plugged into the equation make both equations make the left side equal the right side in both instances. So let's go ahead and take a look at this first one here. 1a, y equals 4x minus 6, y equals x plus 3. We're solving the system of equations, so we're finding the value for x and y in both equations at the same time that will make the left side equal the right side. Now, we can explain the logic behind solving systems of equations pretty simply. Let's say I have $5. What are some of the different ways I can make $5? Well, I could have 20 quarters, because 20 quarters, quarter each times 20 of them gives me $5. I could have 50 dimes, because at 10 cents for a dime times 50 of them gives me $5. So what we're saying then is if those are both equal to $5, they must be the same as each other. Having 50 dimes is the same as having 20 quarters. It is, because they both equal $5. That's the exact same logic they're using here, except they're using it with an equation. They're saying y is the same thing as 4x minus 6, and then in the second line they tell you that y is the same thing as x plus 3. Well, if those things are both equal to y, then they have to be equal to each other. So we set them equal to each other. If they both equal y, we can say that 4x minus 6 is the same thing as x plus 3. Well, now that we've done that, now we're going to apply the rules for solving equations that we've used for the last 2 years and have really reviewed in the last few days here. We know if I'm solving that equation there, we're going to send variables to the left, which means x is going to move to the left side of the equal sign. Remember, when I move something to the opposite side of the equal sign, I do the opposite, which is why you see them subtracting x. And I'm going to send numbers to the right side of the equal sign, which is why you see them sending 6 over to the other side by adding. So I do that, and I end up with 3x equals 9. Solve the resulting one-step equation. Well, if I want x by itself, which I do, I'm going to have to divide, because this is a multiplication equation. I go ahead and divide by dividing by 3 here, and the result is 3. So now you found one answer. X equals 3. Now what you want to do is come back up here and find y. And in case you've forgotten, the way you do that is you're going to change x in one of these equations into 3. Why 3? Because you just told me that x is 3. You change x into 3 and solve and find the resulting y. In either case, the resulting y will be exactly the same. So I'm going to pick this bottom equation because it looks the simplest. So if I change x into 3, 3 plus 3 is 6. So y has to equal 6. If you do it in the top line, 4 times 3 is 12, and 12 minus 6 is, no surprise, 6. Remember, it's the same values for x and y in both equations at the same time. So 3 and 6 have to work in both the top equation and the bottom equation. Since 3 and 6 are the numbers that work in both equations there, we change x into 3 and y into 6. That means our solution here is 3, 6. All right, let's go ahead and take a look at the next one. X plus 4y equals negative 10, and x minus 3y equals 11. Now this doesn't exactly look like the last question because the last question is already set up to say y equals and y equals. This one doesn't say that. So you have to manipulate the equation to make it say that so we can use the same technique that we used in example 1. Now it doesn't just have to be y equals and y equals. You could also do x equals and x equals. So that's exactly what they've done here, is they've solved both equations for x. All right, so if I'm solving the equations for x, that means I want them to say x equals and then send everything else to the right side of the equal sign. So they took this first equation, x plus 4y equals negative 10, and they knocked the 4y to the other side. Well, if I'm moving it to the opposite side of the equal sign, I'm doing the opposite. So that's why I'm subtracting 4y from both sides. So I have x equals negative 10 minus 4y. With the other equation, x minus 3y equals 11, well, if I wanted to say x equals whatever, that means I got to move the 3y over to the other side. Again, if I'm moving it to the opposite side, I'm doing the opposite. Since this says subtraction in front of it, that means I'm adding to both sides. Adding 3y to both sides. So I do that, and I have x equals 11 plus 3y. So both of these equations have now been solved for x. So since both of these now equal x, I can set them equal to each other and solve what's left. And that's exactly where they propose to go right now. So, since this guy equals x, negative 10 minus 4y, and this guy equals x, 11 plus 3y, we're going to set them equal to each other. So we're going to say negative 10 minus 4y is the same as 11 plus 3y. So, solve the equation now. Well, if we're solving the resulting equation here, it only has one variable. That means at this point I need to send my variables to the left and loads of numbers to the right. So I'm going to go ahead and send this 3y over to the left side. By moving that to the opposite side, I'm going to subtract 3y. I'm sending numbers to the right, so I'm going to send negative 10 over to the other side. That means I'm adding 10. Now, as you can see, what they did differently here is they're sending variables to the right and numbers to the left. We're going to go the way we've learned over the last 2 years. So if I'm taking this and sending y to the left, that means I'm subtracting 3y. And I'm also going to add 10. Again, just me doing the opposite to get variables on the left and numbers on the right. So I have negative 7y equals 21. All right, that's a multiplication equation to be solved by division, of course. So now I'm going to divide across by negative 7. Dividing out negative 7 here. And y equals, of course, negative 3, which even though they did it the opposite direction, does match their solution. All right, so now that we know that y is negative 3, I'm going to change y into negative 3. Doesn't matter where I do it. I can come here and change y into negative 3, or I can come and change y into negative 3 here to find x, which is my other solution. Let's go ahead and do that in that right one, because that right one looks like it's going to be pretty easy. So, I've got 11 plus 3 times negative 3. Well, 3 times negative 3 is going to change into negative 9. So this is 11 plus negative 9. 11 plus negative 9 changes into 2, as you can see. So we now know that x is 2 and y is negative 3. We write our solution as an ordered pair, x comma y, 2 comma negative 3. You can plug that in for the other variable, the other equation rather, for y there, and you'll see you get the same thing. Here you'd have the minus 4 times negative 3. Well, the minus and negative is going to change into plus, so that's going to be negative 10 plus 12, which is going to change into 2, which is exactly what we found that x would equal. All right, let's try one more here and then check it out example. We've got y equals x minus 5 and y equals 2x minus 8. So they've done the grunt work for us. So since they've done the grunt work for us, they have both of these equal to y. Since both of these are equal to y, that means we can go ahead and set them equal to each other. So since y is the same as x minus 5, and y is also the same as 2x minus 8, we're going to say that 2x minus 8 is the same as x minus 5. Okay, let's send variables to the left, so x needs to travel, and let's send numbers to the right, which means 8 needs to travel. So I'm going to knock x off both sides here. And I'm also going to send 8 over to the right side. Adding, again, doing the opposite. That's always how we move something to the opposite side of the equal sign, is we do the opposite. All right, so now I'm going to simplify the result. I've got 2x minus x, which is going to change into 1x. And I've got negative 5 plus 8, which is going to change into 3. So I've got 1x equals 3. 1 times what number is 3? Well, we all know that 1 times 3 is 3. So that means x has to equal 3. All right, so now that we found x is 3, let's find y. Remember, all we have to do is change x into 3 and solve the resulting equation. So if I do it here, I've got 3 minus 5. 3 minus 5 is, of course, going to change into negative 2, which is where the y value of negative 2 comes from. If I plug it into the other equation, 2 times 3 is 6, and 6 minus 8 is still negative 2. So either way, we derive the solution of 3 comma negative 2.